By the term power, here we mean mechanical power. Power is frequently used while dealing with optics also. There the terms are dispersive, magnifying, resolving, and even power of lens. But here we deal with mechanical power. Mechanical power is simply the rate of work being done. Power, capital P, W upon T. Work being done. When the work is performed, naturally energy is transferred, energy is consumed. So you might say it is the rate of consumption of energy. For noting down the unit, work in joule, time in second, this is watt. I have written capital letter for watt because it's based on the name of scientist James Watt. You find here watt second is joule. Kilowatt second, that would be 10 to the power of 3 joule. Kilo stands for 1000. Then if you write it kilowatt hour, hour means 3600 second. So it could be multiplied this way. This is known as unit, very common term while dealing with electric bills. Everybody is aware of this term, unit. In fact, this is short form of Board of Trade unit, but this stands for kilowatt hour. 1 kilowatt hour, this would be equal to 3.6. See here, this becomes 10 to the power 6 joule. You might define it that when 100 watt bulb is used for 10 hours, 100 watt is used for 10 hours. That means product will be 1000 kilowatt hour, and that will be known as 1 unit. So it's very easy to remember and understand as well that when 100 watt bulb is used for 10 hours, it consumes 1 unit of electricity. Again, remember that this kilowatt hour is not the unit of power. It is the unit of energy. When you pay the electricity bill, that is the payment for the energy consumed. Similarly, when two states, two districts, or even two countries deal for electrical exchange or electrical sale purchase, then they talk in terms of electric energy only, not the power. This was regarding power and the term that we use. Now, since work is given by the scalar product of force and displacement, you want power, that means divided both sides by time. This becomes power, whereas distance or displacement upon time, this would be velocity. So power is the dot product of force and velocity, which might further be elaborated as Fv cos theta. By putting theta 0 or 180 degree, power will be maximum, means when force and velocity both are either parallel or anti-parallel. In both the cases, the power consumption or the power transfer shall be maximum. If this angle becomes 90, obviously cos 90 in that case becomes 0. So whenever force and velocity both are perpendicular, the power consumed is 0, as in the case of uniform circular motion. See, in this case, force and velocity both are perpendicular. That's why it is said that in uniform circular motion, no power is consumed. And you know it very well that moon has been revolving around the earth for thousands of years. But since there is no consumption of energy in the whole process, it maintains its motion around the earth as it was thousands years back. And the same thing goes with the earth. Not only earth, all other astronomical objects revolving other, they are following the same thing. In uniform circular motion, there is no consumption of energy.